So the last session before lunch, really hope we can keep your attention. Pretty sure we can, because this is a really fun subject. If you're interested in security, of course, protecting your app data is key. And I'm proud to introduce one of my colleagues, Sebastian Olsson. Give him a hand. And this is, for both me and Sebastian, this is really one of our favorite subjects. This is something we think is fun. This is something we work with almost on a daily basis. We discuss it on a daily basis in the lunchroom and everything. This is what our life almost is all about.
Yeah, and that means it's sometimes hard to boil it down to one session. So if we miss something, or if you want to discuss this more, just grab a hold of us later and we'll talk for hours.
Exactly. So we'll try as much as we can to stick to being done by 12 so that we can go out and grab something to eat. So yeah, bear with us. Before digging into all the details, the technical details of what protecting the app data means, we'd like to set the scene. And this is a very traditional view of how a system works. We have some kind of client connecting to a server, consuming some content, updating some content. The actual data is being stored on the server side. But as you all know, that's not really the case. It's more like we have some kind of application. The application also stores some kind of data, and that's being stored on the client, of course. But still, we have the data on the server side. We have data being transmitted to and from the server. So already there are quite a few things to consider. But the actual view is, of course, a bit more complex. We have the user data being stored on the client, but that might end up on a computer as well through a backup. And backup data might actually be transferred to a cloud also, of course. And we might have several servers involved. We might have a server just for handling the authentication through OAuth, for instance. So where we authenticate towards one cloud service and we use a ticket or a cookie in the actual server we're using for the web application. So we might have web traffic flowing between one node, between two nodes. We might have other data or the same data flowing between other nodes. So there's really no point in talking about clients and servers, because client and server is context dependent. At least we don't see clients and servers being different from a data security point of view. So that's why we call it nodes instead. So, and a node applies to basically anything. Mobile apps, web apps, could be application servers, for instance, for a web service interface towards a mobile application. Embedded systems is also something we consider as being a node. And what's common between all nodes is that they store some kind of data locally. They transmit and receive data through interfaces to and from the other nodes. And for that reason, we need to see data security in a separate node as something implemented in several layers. We can't only secure the data being stored. We must also secure the data being transmitted and the layer between those two, which is the business interfaces or the business logic processing the data. All of these layers need to handle security. If one goes down, that might mean that everything fails. So in other words, That's data at rest, data in transit, and business interfaces processing data. Another way of looking at this is from an attack vector point of view. There are several different types of attacks that we need to consider. On the business interfaces or the application logic, we might have application vulnerabilities. We might be vulnerable to a cross-build injection, for instance, that Sebastian will explain more about later today. But we also have middleware, and middleware, of course, contains vulnerabilities, especially if we don't update our middleware.
And also, one problem with middleware is that they often also contain functionality. And that could be a problem for you because you don't necessarily need all that functionality, and that could turn out into a vulnerability.
Yeah, and that brings us to how important it is to handle configuration of middleware. And tampering and eavesdrop of data in transit, of course, especially if the data is not secured. For data at rest, it's usually functionality that's being used, but quite often also vulnerabilities. But that tends to be more vulnerabilities in the business interfaces and the application logic rather than in implementation of storage. So we're going to talk about each of these areas in more detail and what kind of protection mechanisms we need in each of the layers. We're also going to talk about some of the common mistakes that we see on a daily basis in security testing and security analysis of systems. So, to start with the data at rest. One problem is, especially in mobile applications where applications are sandboxed, one problem might be that we consider the sandbox data being secure. So that it's common that application developers verify data being received from a server, for instance. They verify the format of that data so that it's not okay, so that it's accepted. It's not always the case, of course, that there is some kind of validation. But if there is validation, it's usually where it's put. But people often forget to validate the data when it's being read from the storage. So for instance, if data was received from the server, stored in the sandbox, and then at a later point being read by the application, if we don't have the same validation in that layer, then that might open up for security vulnerabilities, because the application probably assumes a certain format of the data. Another problem could be that we as developers consider the sandbox data being isolated from other applications. And if we're going to show later today examples of when applications utilize platform vulnerabilities to perform privilege escalation and break out of the sandbox so that the sandbox rules no longer apply. If an application does that, then clearly the other applications are exposed to many different types of threats.
And this is something you have to think about with your cloud providers as well, because this sandbox could be your virtual machine in relation to other virtual machines on the same hardware in your cloud provider. There have been several severe vulnerabilities in different cloud providers where you could read memory from other virtual machines, and etc. And that would be the same case here.
Yeah. So, and of course, by design, we might open up for data being accessible or writable by other applications. SD cards is a good example of that. That mostly is the case in Android devices. But of course, still a valid point that if an application stores or reads data from the SD card, we need to understand that that's something that's readable or writable by several applications, and actually by someone with physical access, of course. Another thing that's it was published a lot of details about different capability leaks in mobile devices based on Android, especially in applications that were added by OEMs on top of the Android open source project software. And but it's not only OEM software that could contain capability leaks. It's also your own code. So let's say that you, for instance, have two different apps that are communicating with each other. Then you might expose some kind of interface, or what's called a service in the Android ecosystem. Service or a content provider is another example, where you expose data to the other application. Then if one application has permissions to, for instance, read location data of the device, fine-grained location data of the device, then another application could possibly utilize that interface in a way that wasn't intended by the developer. So maybe the intention was that this is something that's going to be exposed internally, just within my application, or just between my applications. But quite often, this also opens up for malicious applications accessing the same interfaces. I already mentioned backup data being a problem. So what we can do to protect our sandbox storage and store data in general is we can encrypt stored data, of course, but somehow we need to handle the encryption keys in a secure manner. We need to have hashed secrets or strong hash functions for storing passwords, for instance. And not only a hash function that is run one round over the data, because then it's quite easy to brute force, depending on what the data is, of course, the plain text data is. But with passwords or PIN codes, it might be that the length of the input data is not that long. Then, of course, it could be easy to brute force if we have weak hashing. And there are quite many functions in the mobile platforms especially, but of course also in application frameworks, and we should leverage those. In iOS, there is a way to specify that certain files in my sandbox should only be accessible when the device is unlocked. So for instance, if application data, if the device is left unattended, then there is really no way of extracting that data, or at least no easy way of extracting that data from the device without having the user's passcode. Of course, again, if the passcode is 1234 or something like that, then it doesn't serve much purpose. But there are functions like this, and some of this is actually has actually become the default in later versions of iOS. Similar functionality in iOS keychain is something called the this device only flags, where you can specify that these secrets that I store in the iOS keychain is not something that's going to be migratable to backups that get migrated to other devices. And that's also something that's going to improve the security, because that means that iOS can choose to encrypt those secrets using the hardware-based keys. In Android, if you're an Android developer, then you definitely heard about chat preferences. It's a simple way of securing storing key value data. And but you need to ensure that you're using mode private. That's the default. So as long as you don't specify anything else explicitly, you normally have the private protection, which means that it's only readable by that application user account. And I talked about content providers and services exposing data to other applications. We need to make sure that we declare those as Android exported equals false. Because if we don't, then depending on intent filters and things like that, how intent filters are declared for that content provider or service, we might open up for malicious apps accessing our data, which is not the intention. So about backups, we can prevent backups too. The default for Android applications is allow backup equals true. So we need to explicitly specify allow backup false to avoid our sandbox data ends up in for instance, backups towards the Google Cloud or backups through ADB or any other similar backup mechanism to the desktop. In a similar manner on iOS, you can specify in code, you could specify for a file URI explicitly that you don't want this file to end up in the backup. So that's something that's that definitely should be considered. I mean, if you have an application, think about if you store data in the sandbox, think about, do we need that or do we want that data to be migrated to other devices when a user does backup and restore? Sometimes we do, but sometimes it's not that important. And maybe, depending on the content of that file, maybe it's better to set it as excluded from backup. Because otherwise, if we don't, then the easiest way to get hold of that data is just to run a backup through iTunes, for instance. And that's actually something that happens when attackers get physical access to devices. They hook it up to backup tools, readily made backup tools, readily available for normal users, but they use it just for a different purpose, without breaking the sandbox model. So I'm going to hand over to Sebastian, who's going to talk a lot about business interfaces.
All right. Okay, sorry. Yeah, I'm going to start talking about business interfaces, which would be the thing that would protect most of your data. And we're going to go into some problems and some solutions to that. Sorry if my voice breaks there. Some common mistakes with building interfaces in general that we often see is being able to use an interface to reference objects internally directly. Some internal object in your system, may it be a user or a post or something, being able to reference that directly and manipulate parameters. Allowing CRUD, create, read, update, delete operations on all these entities. It's very common that you see operations that you don't even need on these objects. Just because there's an HTTP verb that could do something doesn't mean you should have an interface to do it. Having a simple human-readable protocol format really simplifies for the developers and testers, and also for attackers. It really makes it much easier to find out vulnerabilities in the system. And this goes for friendly names in the interfaces as well. So you need to really think about, find a good level of friendliness in your protocol, not to make it too easy. And that might sound like, yeah, like I'm talking about security through obscurity or something like that, but I'm not. Well, I am. And security through obscurity is not bad in itself. It's only bad if it's your only measure of security. It still adds security. It just should never be your only security. So if you look at big systems, they also have obscurity, but that's not their core security measure. So if we were to find some sort of acronym for this, we could probably figure one out. Now, REST in itself is not a problem, so I don't want that to be a take-home. But a lot of these frameworks and a lot of the ways to build these interfaces really invite attackers to try to reference objects and try to find out how to attack the system. So you should think about this when you make your nice interface, because perhaps your business interface for your specific solution doesn't need to be that human readable. It's not the same thing as implementing the Twitter API or something like that. The insecure direct... Okay, thank you. It is a good point. I mean, if you have these nice human-readable interfaces, it's really easy for an attacker to try to circumvent them. And the attacker in this case is, you even invite people who you wouldn't think would be an attacker. I mean, a normal user who see this interface would probably find ways to work around it. So this is an example. I'm user 123456. I'm going to view my user info on this web page, example.com. That's Swedish there. So this is my user ID. Maybe it's some sort of database ID or something like that. And there are a bunch of problems with the interface, or perhaps at least what it allows me to do. So my obvious start would be trying to iterate this user interface. So even if I'm logged in as 123456, I would try to see if I can get the user info for 123454. And this might sound silly, but this happens all the time. When you have a huge REST interface, you're probably lacking authorization checks somewhere. So you have some options. Someone will probably come with the solution of using UID or some sort of long random string. And that's all good. I think it's a good idea to hide the database ID. I don't think a database sequential ID is a good thing to expose to an end user. So having some sort of random UID is a great idea. I can still modify the UID to view other users' profile. And you have to ask yourself, is the user supposed to be able to view other users' profiles? Probably not. And in that case, why do you present them with a parameter that makes them able to do so? So a better interface would be, for example, just user info or user info current or something like that, where you take the information that you have after you've been authenticated and put that in your session or what have you, and use that to fetch your user info. There are no degrees of freedom here in the interface. But you should always still have your authorization check for every, say, service layer request that you have, just to make sure that nothing goes wrong. Some other common mistakes, we talked about this before and we're going to talk about it again. Known vulnerabilities in middleware. This is just free attack surface, just looking at using old deprecated versions, some special versions that has known vulnerabilities. Using permissive helper libraries is very common. For example, some very fast but weird XML parser that allows, for example, external entity parsing is a common problem. If your XML parser allows external entity parsing, I can send in an XML document with an external entity referencing a file in your file system and get the content of that file out, and also leverage that for code execution and other things. So you need to really lock these types of things down. And often those parsers are really easy to use for a denial of service attack, because they allow ridiculous amount of layers of or levels of XML objects or large objects and what have you. And we're going to talk a bit about this later, but handling concurrency from a security perspective is very important. So when we have this nice REST interface, we need to think about what happens if two calls come in at the same time. And I mean, the normal solution would be to have a transaction, perhaps, and have some sort of right skew check that would roll back the second call. But perhaps that's not the correct answer either, because that could also have security implications. And you could do timing attacks and things like that. So you need to think about concurrency as well. Some basic protections that you need to, and this is not a foolproof solution, this is just what you need to think about all the time. You need to have authentication for all the calls where it's possible. You need to know that you're authenticated if possible. Who is the user that's using this server? And the reason for that is that you need authorization. That is, checking if this user is allowed to do this specific operation. And that could be from a general service point of view, but it could also be your domain rules. That is your customer or your company's rules. What's allowed to do with this object in this specific domain? In this specific case, what should a user like this be able to do? You need to think about that at the start of every interface that you're exposing to someone. So you can strictly limit your acceptable inputs and flows. And this is often based on domain rules. So keep in mind that the input validation is not only about looking for weird characters in a string or something like that. The most important thing is adhering to your business rules. That is your domain rules that have to be validated on each call. So always perform the authorization check based on your domain rules and build security in layers. But you need to think securely and try to think about these interfaces in the term of degrees of freedom. How much freedom do you really need to expose to your users? Moving on to the actual data coming into the application. Let me just check there. Okay. Common mistakes in transferring data is not having any protection at all. This is actually the most usual case. We just have HTTP. And to be honest, there is no good reason to not use TLS for at least web traffic for everything. There is really no good reason. If we could talk about that later if someone has a good reason not to, but there really isn't. One common problem when you start solving this problem is, oh no, it's too performance heavy to do TLS everywhere. Let's just build a logged in secure zone somewhere and then we have the front page with the company information and everything. But this doesn't work because you will probably have the login prompt or a way to get to the login prompt from the front page or the insecure part. And in this case, the attacker will position him or herself in the traffic in the insecure part and then use SSL strip to strip away the linkage to the secure part, thus removing the HTTP part of the traffic. Even if the logged in zone, the secure part is only served over HTTPS, SSL strip will strip that away as it strips away the links to these parts, and the secure connection will be between the attacker and the secure zone. So that part will be authenticated and encrypted, and I don't think that was the purpose of the whole thing. So the whole thing needs to be TLS, or whatever other measure you take. The whole thing needs to be secure, not just parts of it. Another very common problem is offering some sort of fallback. I'm using HTTPS and HTTP in this case, but it could be something else. It could be protocol versions or something like that. That is, for example, if we have a client that talks HTTPS and HTTP, but it prefers connecting over HTTPS with TLS. But if that doesn't work, it will fall back to HTTP. Well, as an attacker, I would just block out all the HTTPS traffic, making you fall back to HTTP. And this has been a common protocol problem with everything from RDP to TLS. So, for example, a bunch of you have probably heard about the Poodle attack against TLS, where you force a fallback to SSL version 3 and then use vulnerabilities or problems with SSL version 3, even if both the client and the server can talk, for example, TLS version 1.2, they won't be, because we will make them fall back to a deprecated version. So you need to only allow the secure versions, and that might sound a bit fuzzy, but you need to find out what is your what are the minimum versions that you need. And in this case, we shouldn't allow HTTP at all. And remember, TLS does not protect your business logic. It only protects the transferring of your data. So it doesn't hide your protocol in any way. Even if you do certificate pinning or what have you, it doesn't hide your protocol. It makes it slightly more complicated to view it, but it isn't hidden. And it doesn't protect from attacks in other areas as well. We see this all the time. It can make you a bit irritated when you go into some sort of secure site boasting their security for the applications. This is secure because we use extended validation SSL certificates. Well, that's good and all, but that has nothing to do with whether your system in itself is secure or not. But I guess that's something to convince managers. So, some example protections you could use. You could use TLS or SSL, SSL would being the older versions, but use TLS, a new version of TLS at that. This is probably your take-home from this, but you could also, if you're really paranoid, add some sort of end-to-end encryption on the application level for your specific application, but very few cases need that type of protection. And I mean, a good one will also be using physical separations. That is not connecting to the internet at all, just using a separate pipe or something. Very few do that. But I mean, that happens in like military and bank grade systems. They often have separate networks instead. So, I'm going to quickly talk about SSL and TLS. Just a quick question. Can someone just say the most important part about what's the point of using TLS?
Come on, it's not lunch yet.
Yeah. Yeah, you mean it's encrypted? Yeah. That's exactly what I was expecting you to say. Confidentiality is what people associate with TLS. And that's true, that's an extremely important part of TLS, encrypting stuff. But that's not all. Equally important, and sometimes more important, are authenticity and integrity. You need to be certain that you're talking to the right server and that data has not been modified in transit. Otherwise, the encryption is worthless. What does it matter if I encrypt something to an attacker? That doesn't matter at all. It will add some sort of extra points, of course, for reading previously sent data or something like this, but you need to keep in mind that all of these three parts of the protocol need to be in place. Otherwise, it's pretty much worthless. And this goes for other protocols as well. We see often that people have their custom homemade protocols just encrypting something with AES or something like that. That's worthless. You're open to a whole bunch of attacks just within seconds. So you need to make sure you're talking to the right server. Because you can think about it this way. Sometimes authenticity and integrity is more important. Take your normal use case if you're using an internet bank and you're transferring 100 crowns to someone. Is it more important to you knowing that you're transferring 100 crowns to the right person, or that no one is seeing the information, the fact that you are sending 100 crowns? Most likely it's more important that you're talking to the right server. And in most cases this is the most important. But not in all cases, because in a lot of cases confidentiality is most important. But you need them all. In TLS, just quickly, the handshake, the client sends and opens the connection, the server responds with a certificate, and then the server proves the fact that it has the private key to this certificate. And a man in the middle would not have the private key to this certificate, so without owning the private key or somehow interfering or finding a vulnerability in the protocol, they cannot interfere or intercept traffic. And that's the whole point of it. So there are, though, quite a few problems with TLS or implementations of TLS. It is very complex. There are too many options most of the time. Extremely many options. This is the main problem. It's been around for a while. It's built for browsers, not for apps. That's not a problem in itself, but that also speaks a bit for the fact that it has a lot of options. And in your operating system, you often have more than 100, often up to 200 certificate issuers that you're accepting that could have issued the certificate in this case. But normally, when you're developing an application, for example, you don't use 200 certificate issuers for your application. Normally, there's just the one. So maybe you're not interested in trusting these foreign entities of some sort that could also sign a certificate for your domain. Or perhaps you don't even trust your issuer. Maybe you want to pin it to a specific certificate that issuer has given you. In that case, you're even secure if your issuer is breached. And one big problem is that users can actively choose to bypass certificate validation, because like I said earlier, TLS is worthless unless you have authentication. And it's often possible to easily bypass authentication, and people tend to do it. Using weak cipher suites and SSL versions is also a problem. I'm not going to go into details here. We can discuss it later if you're interested. But the main point being, try to limit the versions of ciphers and SSL or TLS versions you allow. For example, if you have an application and you know the platforms, then you can find the minimum required SSL versions and cipher suites that you could use. And client authentication is sadly a bit complex to do in TLS. It actually exists. You rarely see it. It's mostly used machine to machine because there's a problem with provisioning certificates and also pretty complex to implement. It's very good, but it's very hard to implement. We also have the platform vulnerabilities, obviously, since these platforms are everywhere. So this is something we see every now and then. Maybe you've searched Google after you have your problem with the certificate validation failed of some sort. You get your error message and your exception, and it just won't work. And then you see a post for a solution on Stack Overflow with 300 upvotes, and everyone's happy. Oh, thank you very much. Now it works. No more problems. You see something like this, just bypassing certificate validation. And this is totally unacceptable. It says, don't try this at home here. It should probably say, don't try this at work. There is actually never, ever, ever a reason to do this. Not ever. Not even just the one case you're thinking of.
Not even at home?
Not even at home. Not even just for fun. There is really no reason to do this. And when you're doing this, you might as well just spend your time doing something else than using TLS, because it is worthless if you don't have authentication. I think I mentioned that before. So, what can you do then? You should use TLS as basic protection. TLS isn't dead. It just smells funny. And you should try to increase the security by preventing weak SSL versions and cipher suites. And also do this on the client side, if it's possible. It's not always possible. For example, with the go-to-fail vulnerability, you could have just bypassed the platform vulnerability by removing a couple of cipher suites. But you could also not do that with the basic URL connection that most people are using. So if it's possible, you could limit there as well. And with certificate vulnerability, once again, never bypass this completely. If it's possible, you could limit what you trust. Do that if it's reasonably simple. Don't do it if you think you might end up with worse security. And try to stay informed on the platform vulnerabilities. And nowadays, that's pretty much watching the news, because this is very important stuff. So you don't need to read the most hardcore security newsletters or something like that. You mostly just need to keep your eyes open. Just for fun, if you're using HTTP, you could use some extra measures such as these nice acronyms HSTS and HPKP. This stands for HTTP Strict Transport Security and HTTP Public Key Pinning. Both are headers that you can send from your server to tell the client the next time it will talk to this server, it should force HTTPS, even if the user doesn't type in HTTPS in the browser. Or in the HPKP case, we add a couple of public keys. Certificates have public keys. We add a couple of public keys as pins, so that next time we request this site, we only accept certificates that have these specific public keys. You need to do this right. If you want to talk about the details of these and also possible attacks on these, we can take that outside later, because there are a couple of attacks. The most obvious one being the fact that you don't have this information until you actually made the first call. In the case of, for example, Chrome and Firefox, they have a setup where they load a set of sites that are preloaded with both public keys and transport security. settings. And you can even get on that list for Chromium if you have a really high-profile site by trying to get on their JSON list of sites that are preloaded into Chrome. But still, traffic can still be extracted in many cases. It can't necessarily be read or changed between the server and the client, but the traffic in itself, like I said, does not hide your protocol. So if I want to find out how your protocol works, TLS does not hide that. Classic case would be in just recompiling your application, for example, and removing the certificate pinning that you're doing, or interfering with some sort of web proxy. Even better, we could add system hooks to the system and just read out the unencrypted data at the operating system level. So in summary, data must be protected in several layers, both against attackers and malicious code. We didn't talk too much about malicious code here, but we'll do later. And the security of TLS depends on which versions and cipher suites that you allow. And the easiest way in general to fix all these problems, or at least make the amount of vulnerabilities lower, is to limit your interfaces. Think about the degrees of freedom. Does your interface need to be able to change the user ID? Do you need to support SSL version 3? Just look at all your configurations and all your input parameters and lock it down. That's how you normally remove most of your security vulnerabilities, because most applications need very, very few degrees of freedom and allow very many. So I think Emil is going to do a demo here.
Yeah, it was making some last-minute changes, so it's probably not going to work.
Okay.
But let's give it a try. Just realized that I had the wrong IP address. That's a classic one. So Sebastian talked about the fact that SSL or TLS does, of course, not protect our protocol logic. And I thought I'd spend 3 or 4 minutes on demoing a new tool that we developed. So let's hope we have the demo guys with us. I'm using ADB shell just to run on this Android emulator. And you can see that there is a shim library preloaded here. And using setprop, we can specify a value of the LD preload environment variable to preload that library into the Android browser process. So this could be done with any application process. I'm just using the Android web browsers since I didn't spend time on writing a proof of concept application for this. And I also need to launch a logger server. So let's see if we can launch the browser. And if you're an Android developer, then it's no big news that the Android emulator is extremely slow. This is something else. Let's type in a HTTPS URL. Let's use, Google. And you can see, well, this might not look as plain text data, but it actually is. It's just compressed using gzip. So you can see all the header data, cookies and everything. So this is something that we use to get a quick overview of how the application works and how the application protocol works. So even if the application has some kind of certificate pinning, and we can bypass that completely using these types of system hooks. So this is really powerful, especially as a simple testing tool. And in addition to this, this is at a really early stage in development, but we are also logging a lot of other system calls. Not only logging, actually, we're actually intercepting. So we could change the return value of these system calls. For instance, if the application checks the value of a system property, we could intercept and modify that value being returned. The system checks for the existence of a certain file. At an earlier point in time, there will probably be some kind of open or fopen call being made. You see there's tons of output. Here's an open call. So you could see this is opening this file, and this is the file descriptor being returned. So at a later point we can see when this is being used in an fstat call or a read call or anything like that. So we have complete control. As long as we have complete control over the system, then there is no problem in analyzing the application. So obfuscation and things like that doesn't really serve much purpose in this kind of context. But I really think it's time for a lunch break. Hope to see you back by 1 o'clock sharp. The next session is
Secure coding patterns?
secure coding patterns. Thank you. So see you back at 1 p.m. Thank you.